Good evening, and welcome to another installment of Reading with David. Tonight we'll be taking a look at George Buscombe's Television Theory and Servicing. If you've got yours, go ahead and open up to page 245 if you'd like to follow along. And we'll start with Chapter 8. Horizontal Sweep Section, Oscillator, AFC, and Driver Stages. 8.1. Introduction. The horizontal sweep circuits, especially the output stage, of color sets in particular, are the most complex and hardest worked of any in the entire receiver. Small wonder, then, that this is where the vast majority of defects occur. The major stages of the horizontal sweep section of a set, including the HV and some interfacing circuits, are shown in the block diagram of Figure 8.1. Except for the heavily outlined blocks, which are peculiar to color sets only, most of the stages are found in both black and white and color receivers. This chapter is concerned mainly with development and synchronization of the sweep signal, and the stages involved are the oscillator, or countdown circuit, the AFC, automatic frequency control, circuits, and the driver amplifiers. Although AFC performs a sync function, it is considered at this time because of its close relationship to the oscillator, which it controls. Other sync information is contained in Chapter 10. The output stage and related circuit functions are covered in Chapter 9. Horizontal deflection of the CRT beam is the primary purpose of the sweep section, but there are numerous spin-offs, as indicated. 8.2. Functional description of horizontal stages. A brief overview description of all blocks is as follows. There are three separate categories: beam deflection circuits, synchronizing circuits, and sweep-dependent circuits. Beam deflection stages. This indicates the stages that generate and amplify the sweep voltage to drive the yoke, as described next. Horizontal oscillator. This stage generates the sweep voltage. The frequency of oscillations, which must be very stable, can be manually adjusted with the horizontal hold and/or frequency controls. The sweep frequency for a black and white set is 15,750 Hz, and slightly lower, 15,734 Hz, for color. Instead of the conventional oscillator, some modern sets use the countdown system, as described in Section 7.9. Horizontal driver amplifiers. There may be 1, 2, or even 3 such stages. As with vertical drivers, see Section 7.11, the purpose is twofold: to amplify the weak sweep voltage generated by the oscillator to adequately drive the output stage, and to act as a buffer to prevent loading of the critical oscillator circuit. Some drivers also act as a wave shaper to develop the sawtooth waveform required for linear beam deflection, but most develop a square wave for switching the output stage. Instead of the conventional oscillator amplifier arrangement, some sets use SCR switching circuits, as will be described later. Output stage. This is a power amplifier that drives the deflection yoke via the output flyback transformer to sweep the CRT beam the full width of the screen. The amount of deflection may be varied with a width control. The damper is a diode that prevents excessive ringing in the yoke. Other blocks, Figure 8.1, associated with the output stage perform a variety of functions, as will be described later. Beam synchronization. To synchronize the developing picks with the station, the oscillator is controlled by the incoming sync pulses via the sync stages and some form of AFC, automated frequency control, circuit, as follows. The AFC circuit is responsible for keeping the horizontal oscillator locked in frequency and phase with its counterpart at the station. It does this by comparing the incoming sync pulses with a sampling of the generated sweep voltage. Sweep-dependent circuits. These sweep-related circuits are tied in with the output stage as shown in Figure 8.1. Some are used in both black and white and color sets. Some are found in color sets only. They are briefly described as follows. Horizontal retrace blanking. As with the vertical sweep, section 714, the CRT beam must be blanked out during horizontal retrace intervals, and it is done in the same manner, by applying a high-amplitude horizontal sweep pulse to overbias the CRT at the proper times and for the duration of beam retrace. Early model sets fed the blanking pulse to the CRT directly. Late model sets, with direct coupling, feed the pulse to the video amplifier. Control pulses. A number of circuit functions, especially with color sets, are gated or keyed by the horizontal sweep. These control pulses are generally supplied from tertiary windings on the flyback transformer. The pulses must be of specific amplitude and polarity according to the circuit being controlled. More on this later. Dynamic convergence, color sets only. As with vertical, section 714, a modified sweep waveform is applied to the horizontal coils on the convergence yoke of a triad-type CRT to maintain good convergence of the beam at the screen edges. Horizontal pin cushioning. This circuit also has its counterpart in the vertical sweep section, section 714. It is found on large screen sets to prevent raster distortion where raster tends to bow inward or outward on the left and right sides. Correction is accomplished by feeding a portion of the vertical sweep voltage to the horizontal yoke. Sweep-derived power supplies. A number of DC supply voltages are derived from the horizontal sweep section. They are as follows. 1. HV supply. The HV required by the CRT is obtained by rectifying the stepped-up voltage from the flyback transformer. With a black and white set, depending mostly on the screen size, the HV is usually about 15 kilovolts or so. For a color set, it is much higher, 25 to 30 kilovolts or more. The current drain, beam current, however, is very low, seldom exceeding 200 microamperes for a black and white set and 1 microampere for a color CRT. With color sets, the HV is regulated and adjustable. There are also special disabling or shutdown circuits as protection against potentially harmful X radiation should the HV become excessive. 2. Focus voltage. A color CRT requires 1000 volts or so for the focus anode. It is obtained by rectifying the high pulse voltage of the horizontal output or from a separate winding on the flyback transformer. For beam focusing, the voltage is varied either with a potentiometer control or an adjustable coil shunted across a flyback transformer winding. 3. B-boost and other secondary power supplies. More and more sets are utilizing the horizontal sweep section to supply the DC current requirements of various stages. Commonly known as scan rectification, different amounts of voltage are provided by individually rectifying the outputs of separate windings on the flyback transformer. Except where high current is involved, the use of scan rectification has several advantages over the conventional 60 Hz LVPS. Greater efficiency, less heat and power consumption, and less filtering required because of high-frequency ripple. Section 8.3, Horizontal Sweep Circuit Fundamentals. The horizontal sawtooth waveform is developed in the same manner as the vertical sawtooth, section 7.6, that is, by alternately charging and discharging a capacitor in either the oscillator stage or one of the driver amplifiers. The charge cycle, while the transistor is non-conducting, corresponds with the active left-to-right trace of the CRT beam, and the discharge cycle, initiated when the transistor is turned on, relates to horizontal retrace. The amplitude of the waveform, and hence the raster width, is determined by the amount the capacitor becomes charged and discharged in the allotted time, as established by the time between horizontal sync pulses. Since the time intervals are much shorter than with the vertical sweep, the C and R values in the circuit are considerably smaller. As with the vertical sweep, the shape of the waveform, applied to the yoke, determines the linearity of the beam trace and, in this case, the horizontal proportions of the picks. Figure 8.2 shows some examples where abnormal wave shapes stretch or compress the pics in different areas of the screen. Also see Figure 7.3. Most solid-state receivers do not have a horizontal linearity control. For the AFC circuit to lock the pics in sync, the oscillator must be adjusted to free run at the correct frequency. The hold and frequency controls are provided for this purpose. Good night and sweet dreams.